And welcome back to Algebra 1. We are using as our text the Algebra 1 second edition from Bob Jones University Press. And I'm coming to you live and in person. Not, but I'm recording this live from the Rockwall County Public Library. Before we begin, we have two lame jokes today. Actually, they're sort of riddles. The first one I think is so old that you'll say, why am I even bothering to say this? So, what goes up when the rain comes down? No, of course, umbrella goes up. If you're smart enough to have the umbrella in your van when it's raining instead of at home. The second riddle, though, I need to read this one to you, and I'm going to let you think on it for a bit, and at the end of this video, I will tell you the answer. Walk on the living, they don't even mumble. Walk on the dead, they mutter and grumble. What are they? Now, I'm not a fan of the Lord of the Rings trilogy, but I think that in that story they did lots of riddles. So, walk on the living, they don't even mumble. Walk on the dead, they mutter and grumble. What are they? So that's your riddle for the day. We're going to go ahead and resume our study of algebra with section number 9.6, which is factoring trinomials of the form ax squared, let me see where I can be here, ax squared plus bxy plus cy squared. Now at first glance, that might look a little bit confusing to you with all of these letters in here, but let's remember what we were studying just last section. We had the pattern that said we're going to factor trinomials that look like this. The only difference here is that we've added a second variable. We have a variable in the first term and a variable in the last term. If we had an example of a problem that we wanted to factor from last time, that could be something like 3x squared plus 5x plus 2 plus 2. 3 is in the place of the A, 5 is in the place of the B, and 2 is in the place of the C. And we learned that from our knowledge of using the principle of FOIL, what two expressions do we factor together to end up with 3x squared? We have a 3x, and you have an x. But we also have to factor in the possibility of having the 2 and the 1, and this is where we realize that our last factors are going to have to multiply together to give us a 2, but the sum of the outer and the inner products is where we had to be equal to 2 as well. So we saw that we had a couple of different choices that we could use. We could put this in the form 3x plus 2 times x plus 1, or how far down can I go? That's about as far. The first product is 3x squared. The last product, of course, is 2. And then what we did was we found the sum of the outer and the inner products. So the outer product, does this fit here? Yes, the outer product is equal to 3x times 1. And the inner product is 2 times x, which was 2x. And when you summed them together, you got the 5x that we were looking for. So this pair of factors here was actually the solution. We had another option in how we arranged these, however. We could have put 3x plus 1 and x plus 2 as a possible way of arranging these factors. This is correct. This one isn't. Well, why is it not correct? Well, I just demonstrated to you that when we summed the outer product, the outer partial product, and the inner partial product, we came up with our middle term, which is 5x. Let's see what happens if we sum the outer partial product and the inner partial product of these two binomials? Well, the outer partial product is 3x times 2, 3x times 2, which is 6x. Okay? The inner partial product is 1 times x, 1 times x, which is equal to x. When you add together, when you find the sum of these two partial products, 6x and x, you have 7x. Well, are we looking for 7x as our solution? No, we need the 5x. So what we're going to be doing in section 9.6 is exactly the same as what we've been doing already, with this one simple addition, is we add a variable to the trinomial. Now watch what happens. 3x times x, right here, 3x times x gives us x squared, right? But we also have to have this xy. What's going to give us 2y squared when we multiply together? 1y times 2y. Of course, we don't need that 1. And what is y times 2y? Well, you get your 2yx squared. So let's see what happens. For this to be the correct form, FOIL, our first product is, let me see, I can't even see this. First product is 3x times x is 3x squared. The outer product, 3x times 2y, is 6xy. The inner product is, that still you can't see, 6xy. And the inner product is xy, which gives us 7xy. We need 5xy. So you're just going to change our factors around, 2y and y. Now your outer product, 3x times y, 3xy. Our inner product, 2y times x, is 2xy. You add those two together, 2xy plus 3xy, and you get the 5xy. Now let me go back past our introduction and just begin with a little bit easier problem. Before I do that, I'm going to walk over here and I'm going to zoom this out just a little bit because I'm not being able to get as much on this screen as I need there to be. And we'll see how that will work. I want to be able to go ahead and get everything on this video without having to edit it. So I'll be doing a little bit of walking back and forth. Like right now, I forgot to flip my screen around, so I'm not able to make sure that I'm in the picture. So now, I have flipped my screen back around and hopefully we'll be able to continue recording quite conveniently. Let me stop my scan, make sure my upload. Okay, my computer tells me that section 9.4 is uploaded and will be active, and it's now noon on Tuesday. So, after that introduction to section 9.6, let me go ahead and look at this example. This is example 1 on page 384. And it wants us to factor, how much space do I have? Factor 2x squared minus 3xy minus 14y squared. Nothing to be afraid of here. We just have an x squared term, and we have a y squared term. That means that in both of our binomial factors, we're going to have an x and a y. We know that we're going to have one binomial times another binomial. We also know what are the signs of these binomials going to be. Well, one's going to have to be negative and one is going to have to be positive, because when you multiply the last terms together, you have to come up with a negative, okay? But first, let's go back to the very beginning. When we look at this, is there any common monomial factor that we can pull out first? Like, is there a factor of 2 in common? No. 2 is prime and 3 is prime. There's no common numerical factor. There's no common variable factor. This is not the difference of two squares. This is not a special product, because neither the first term nor the last term are perfect squares. So we're just going to have to go ahead and factor it. So we want to go ahead and factor our first term as usual. 2x squared. It's going to fit here. Okay, 2x squared is equal to 2x times x. There isn't any other way that you can come up with a factorization for 2x squared. So we're going to put our 2x and our x as the first term in our binomial factors. Now, could I put x here and 2x as a second one? Yes, but it's just a habitual way of working to put your larger factor first. Doesn't matter, but it's just a habit. Now, we're going to have to factor our last term, including the variable. So, how are we going to end up with a y squared? We're going to have y times y. So we have 14y squared. Can you see all of this here? Yes, 14y squared. That can be y times 14y, or it can be 2y times 7y. Is there any other way that we can factor 14? No, you can say 1 times 14 or 2 times 7, because both of these are prime factors here. Now let's see what your book says. Well, we have to find the combination of factors here so that when we add together our outer and our inner partial products, they're equal to a negative 3x. So, what possible combinations are there? Well, let's go ahead and see. We already have our 2x times x. And we know that our choices are going to be 1y and 14y, or 2y and 7y. Let's just take a look and see. Okay. Minus and plus. Let's see what happens if we use x's for our factors of 14. Let's do 1 and 14. We're going to have a y in there as well, so that when we have a negative y times a positive 14y, we end up with a negative 14y squared. Remember, I said since we don't write the understood 1 in front of the variable. See what happens. What's our outer product equal to? 2x times 14y. Well, you can already tell this isn't going to do us any good. 28xy. Our inner product is negative y times x. That's negative xy. And their sum is 27xy. What you learn from this, though, is that we're on the right track, because our variables here are x and y, exactly like they need to be. So the square root of x squared is x. The square root of y squared is y. So we have factored the variable portion of our problem correctly. But that particular arrangement of factors doesn't give us what we need. The outer product and the inner product summed together have to be equal to a negative 3xy. So let's change this around. Instead of having negative 1, positive 14, let's have a negative 14 and a positive 1. Since we have the variable, we're just going to write that as a positive y. What's our outer product? 2x times y, 2xy. Our inner product, negative 14yx. Put those variables in alphabetical order, add them together. We have a negative 12xy. It's better than what we had to begin with. It's still not what we need. So our factors of 14 and 1 are not what we're looking for. The only other way that you can factor 14 is 2 and 7. So let's see what we're going to need to be able to solve this problem. Negative 7y and a positive 2y. Let's see what we can have. Outer product, 2x times 2y, 2x times 2y is equal to 4xy. Inner product, negative 7y times x is equal to negative 7xy. What happens when you add them? You end up with a negative 3xy. This is exactly what we're looking for. So we now have factored our trinomial properly. It's interesting whenever I have to use this particular room in the library, because it's one where everybody can see everything that I'm doing. So they come by and they make funny faces at me or they smile. Let's see what would have happened, however, if we had changed this order. Instead of a minus 7 and a positive 2, we had a minus 2 and a positive 7. Our outer product is 2x times 7y, which is 14y, 14xy. Our inner product, negative 2y times x, is negative 2xy, which sums to the 12xy, which verifies for us that even though there are 4 possible combinations of binomial factors that we can come up with here, only one of those arrangements yields the correct answer. So what you have as the solution to this problem, your instructions are going to say factor this trinomial. Factor 2x squared minus 3xy minus 14y squared. 2x minus 7y times the quantity x plus 2y. You always, 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 when you have come up with your binomial factors, you want to check it. 2x squared, outer product, whoops, plus is not necessary, plus 4xy, inner product, minus 7xy, and last product, minus 14y squared. Combine like terms, 2x squared minus 3xy minus 14y squared. Make sure that your product, when you use FOIL, let me see here, yes, that your product, when you use FOIL, is the same thing that you started with. Well, Miss Betsy, do I really have to check it? Problem doesn't tell me to check it. Well, no, you're correct. The problem does not tell you to check it. But to me, it makes no sense. It takes you 30 seconds, 10 seconds, 2 minutes to check your problem. 2 minutes if you're having a hard time and you're texting 5 people in the middle of checking your work. Take the time, and it will, your tests then are self-correcting. You'll know if you've gotten the correct answer. So that's example number 1 from section 9.6. Let's see what example number 2 is. We have 18a squared, 18a squared minus 57AB plus 35B squared. Let me make sure that all of that's on the board. And it is. Our instructions, once again, simply say to factor this problem. Is 18 a perfect square? No. So this cannot be a perfect square trinomial because the first and last terms have to be perfect squares in order for them to be a perfect square trinomial, which is a special product, which is once you learn that pattern, you know what the binomial factors are. Well, is this the difference of two squares? No. Difference of two squares is a binomial. This is a trinomial, plus the terms are not perfect squares. So we're simply going to have to factor this trinomial. Now the next thing that we want to look for is, what about monomial factors? Monomial factors. Is there a factor that is in common that we can pull out from this trinomial? This is that reverse distributive property where we learn that if there is a greatest common factor in your trinomial, this outside factor here is that greatest common factor. So let's see. A squared, A, B squared. There are no common variable factors. However, we have 18 and 57 and 35, and I'm thinking there surely is a common factor in here. In order to be able to figure out what your greatest common factor is, you need to know how to factor these numbers. I'm going to look at this and say, okay, well, I know that 35 is 5 times 7. 35 is equal to 5 times 7. Both of these numbers are prime numbers. So if I have a factor of 7 in common or a factor of 5 in common, then I can go ahead and pull out that common factor. Well, let's look here. Is 5 or 7 a factor of 18? No. That means that there are no common monomial factors in this problem which you can pull out. Which means that your factoring is going to be a little bit more complicated. No common monomial factor. And this is one where, as you're now at the beginning of learning how to factor trinomials, it might take you a little bit longer. Matter of fact, it probably will take you a little bit longer. This problem might take you 10 minutes to figure out. It might take you 2 minutes to figure out. But you're having to factor the first term. How can you factor 18a squared? Well, 18a squared can be 1 times 1, it can be a times 18a, it can be 2a times 9a, it can be 3a times 6a. Different methods, 3 different binomial combinations of factors so that you come up with 18a squared. Well, what about 35b squared? How do you factor that? B squared, that can be 5b times 7b. Or it can be b times 35b. Now, it's not the most common thing for the larger factors where you just have the number times 1. That's usually not going to be what the factors are. So I start, when I'm doing my trial and error, I leave the 1 times 18 or the number times 1, 35 times 1 as my last trial. So I'm just going to go ahead and take those out. And now, this doesn't look quite so bad to me because we only have one combination here. We're going to have a 5b, and we're going to have a 7b. 5b, and we're going to have a 7b. In all likelihood, it's not going to be b in 35b, though it could, but we're going to try with this first. What are our signs going to be? We have a negative in the middle, but we have a positive at the end. The only way that you can have a positive product of factors, yet a negative sum of those same factors, is if both of those factors are negative. Okay? We have a negative 5b times a negative 7b gives us a positive 35b squared. Now, what are we going to do for our first term? Well, a squared, 18a squared factors as 2a times 9a. It also factors as 3a times 6a. In all likelihood, some combination of these factors will give us the negative 57 that we're looking for. So let's make some wise guesses here. And I'm going to look at these and say, okay, 9 times 7 is 63. 2 times 5 is 73. I don't think that's going to be, but I am thinking right here, look at this one. Because we're going to be adding these two factors together. What is 6 times 7? It's 42. 3 times 15, 3 times 5 is 15. 42, 15. Look at that, you've got 57. Okay, 6 times 7. We want that to be a 6a. 3 times 5, 3a. Now let's look at this and see if we have arrived at our proper pair of factors at the beginning. First terms, 6a times 3a had better be 18 squared, which it is. And I'm going to stop right now, not FOIL. We're just going to do our outer and inner products. What's our outer product? 6a times a negative 7b. 6a times negative 7b is a negative 42ab. That show up? Yes. Negative 42ab. What's our inner product? It's a negative 5b times a positive 3a, which is a negative 15ab. You have to take the sum of the outer partial product and the inner partial product. You have negative 57ab, which is what our center term is, negative 57ab. And you can see in this problem where we're putting together all of the different concepts and properties that we've already learned. You have to know how to add positives and negatives. You have to know how to factor. You have to understand how variables work together. When you practice more of this trinomial factoring, it will become easier and easier and easier for you to be able to come up with your binomial factors immediately, like I did here. I'm going to go ahead and erase this very quickly. Just work through them all so that you can see that you don't have to be able to figure these factors out as quickly as I did. We had 18a squared. We have to find possible factors of 18a squared to put in here. And I do suggest that you not use 1 times 18, that you not use those larger, the extreme small and the extreme large factors as your initial trials at the beginning, because usually it's not what you're looking for. So 18a squared can either be 2a times 9a, or it can be 3a times 6a. both of these, their products, are going to be 18a squared. So let's try first with 2a and 9a. This negative 5b and negative 7b, the only other two factors that you could have that would be a positive 35b squared would be a negative b times a positive 35b. And since that's another one of those where you have an extremely small and an extremely large factor, we're going to try our 5s and our 7s first. And just to verify, our first terms together, 2a times 9a gives us 18a squared. Negative 5b times negative 7b gives us the 35b squared that we need. Now all we have to do is see what our outer products are. Our outer product, if I could possibly write a 0, our outer product is 2a times negative 7b, which is negative 14ab. Our inner product is negative 5b times a positive 9a, which is a negative 45ab. And this might very well have been the first one that you worked with. Would have been just fine. Negative 14 plus a negative 45, what's it equal? Say negative 59ab. Close, not close enough. There's a saying that close only counts in horseshoes and hand grenades. Sort of macabre to say counts in hand grenades. But anyway, negative 59, negative 57 doesn't work. So this particular pair of binomial factors is not what we're looking for. So let's switch it around. Instead of having 2a and 9a, let's have it be 9a and 2a. The outside terms would be 9a times a negative 7b, and that would be a negative 63ab. Okay? The inside terms would be negative 5b times 2a, which is a negative 10ab. Well, we're getting worse. Negative 73 is even further away. So we know that our factors of 2a and 9a are not involved in our solution. Let's keep on trying. 3a and 6a. 3a and 6a. Our outer product, 3a times a negative 7b is negative 21ab. Remember, I've said you've got to have your multiplication products down really well. Multiplication facts down really well. Our inner product, negative 5b times 6a, that's a minus 30ab. Once again, we're close to what we need our inner term here to be, but close doesn't work. So we're going to switch the order of the 6 and the 3. We have 6a and 3a. Outer products, 6a times a negative 7b, negative 42ab. Inner product, negative 5b times 3a is a negative 15ab. You sum these, and you end up with, if I were able to write, a negative 57ab. The sum of the outer partial product and the inner partial product is a negative 57ab, which is this center term that we're looking for. So the solution to our factorization is, to our instructions to factor this problem. 18a squared minus 57ab plus 35b squared is the first binomial factor, the quantity 6a minus 5b, times the second binomial factor, the quantity 3a minus 7b. Now, when I was working this problem, I wrote and I erased, and I wrote and I erased, and I wrote and I erased. That's because I don't have a whole wall full of blackboard here for you to be able to see. Do not erase your work on these problems. Do not erase your work. Okay? Don't erase your trials. Doesn't matter that they're not right. That shows me that you understand what you're doing and how you're actually working. That's the oh, I guess I ought not to do the conclusion. Let me see if I can pull up my computer screen again here. Say section 9.5 is loaded, and section 9.6. I'm sorry, it's section 9.4 and section 9.5 are now active at 12:30. This is section 9.6 that I've just completed, and I will be converting this and hopefully having this uploaded. My boys will upload this while I'm teaching y'all tonight. But back to the riddle that we began this tape with. Walk on the living, they don't even mumble. Walk on the dead, they mutter and grumble. What are they? Well, they are fallen leaves. Dead leaves, you know, if you have live leaves that fall, they're still soft and pliable, and they're quiet. But you know what it's like in the autumn when you crunch all over those dead leaves? So the answer to the riddle is fallen leaves.